So let's get started. Fewer people. Is there anybody in here who's still on the wait list? All right. All I know is I got an email this morning that said they were trying to hire another TA to allow 30 more people in, so. You're there. All right, so our goal here is to talk about virtual machines, containers, isolation, functions, serverless, functions as a service. Start you thinking about the capstone. You realize, you're like, hey, wait a minute, it's the beginning of the second week. Do I have to start thinking about the last week? And the answer is, yeah. This is actually the fun time when you can sit down and say, what do I want to do? Rather than the crunch time when you go, holy shit, this is due tomorrow and I haven't started it yet. So use this time to think about, hey, I'm going to build my startup company. And you laugh, but I actually had at least one person in last term who not was talking about building a startup company, he was already building his startup company. And in the end, his capstone project was a lot of what he was doing in his startup company. So think about that. I think there was somebody in here who was doing a startup company. So start talking about the capstone, talking about how you actually take things that are part of your contract, part of your requirements, and turn them into actual tests. Discuss ethical lenses for considering things, and think about one of your clause control tests, just as an example. And then I will note that the biweekly check-in, the first biweekly check-in is due Thursday before class, and it opens after class today. It's intended to be a very short exercise, 5-10 minutes kind of thing. Part of the reason it's important to me is that it's your chance to say, here's what's getting in my way. And by having that on Thursday, by the following Tuesday, a week from today, I'll be able to come in here and say, here's what I've done. Here's what I learned. Here's what I've done. So this is direct feedback with a short return on it. Because I know the tendency is that people won't actually tell me when something is wrong. You know, it's like trying to get ChatGPT to tell you something negative. It won't do it. I mean, have you ever noticed that with ChatGPT or any of these LLMs, right? They really want to, like, please you. It's kind of annoying after a while. You need a little more friction than that for creativity. So, what are the boundaries? What are the things that you're assuming here? You know, it's like, what are you assuming when you run something on a particular kernel? So this is an interesting aspect of containers. How many people here have ever used a container before? I mean, I've got Docker running on my laptop, right? I mean, it's kind of thin. I only have 64 gig of memory on it, and I really, if I were rich, I'd probably buy 128 instead. But right now, memory's like crazy expensive, like double the price now than it was just a few months ago. And currently, my understanding is that all of the memory is sold out for 2026, which basically means that anybody who's sitting on memory can basically jack the price up. You know, it's sort of like selling water in the middle of the desert during a heat wave. You can charge whatever you want. 64 gig is enough to run some containers. It's perfectly fine. Odds are, if you've run a container, what you've been running is an Ubuntu kernel. An Ubuntu distribution with a Linux kernel, which will be the kernel for whatever the distribution was, because nobody's going to go in there and tinker with that. Do you have to use Ubuntu? He says yes. Now I want somebody who disagrees to say no. And then I'm going to have you guys fight it out. We'll mud wrestle for it. No, he's like, it's not worth it. What other kernels can you use? Well, you probably want to research that a little bit then. A container, though, isn't running the operating system itself. This is the interesting part about it. What the container actually runs is it runs a set of libraries, and the libraries talk to the underlying operating system. Because when you are sitting there on your Mac and you're running Docker containers, it's not running the OS you think it is. So the container world is acting like it is Ubuntu, but on a Mac, and I'm guessing that that's, an M something Mac. Is it brand new or is it old? So it's an M1 or M2. Right. And the binary that it's running the Ubuntu kernel of is what? He's like, I don't know. It's x86. So how do you actually run a different binary on M1, M2, M3, M4 silicon? I don't know, it's just magic, right? Does it work? I mean, one of the reasons that people use Docker is because it does actually work. How do you do that? I don't know. Go figure it out. It's a good question. I'll just tell you it works, so you don't have to worry about it. Docker runs on Windows. Well, at least it is probably the same architecture, unless you happen to be running an ARM Windows laptop or something. It's the same architecture. So the hardware architecture of the processor doesn't need to be translated, but the Mount Xinu-based Unix platform on which the Mac is based isn't exactly the same as Linux either. But it's more like Linux than Windows is. Anybody know how they make it work on Windows? See, I'm a systems person, so for me, I grew up with all this stuff. Something else for you to investigate when you're thinking about that. But the beauty of Docker is that you can take almost any standard Linux package, stick it into a Docker container, and just run it. When you want to have a database package, you just Docker run whatever the database is, and a few minutes later, boom, you've got a database image running. Of course, there's a problem with that because containers are like little isolation units. So any data you write into the container is ephemeral. It goes away. Shut the container down, anything you wrote into it goes away. Well, that's probably not what you wanted with a database. So maybe what you actually wanted with the database is to have persistent storage. So this is where we start cheating, right? We say, hey, what I'm going to do is I'm going to take some storage from the underlying platform and expose it inside the container as if it was local storage. And now you get this beautiful mixture of the two of them, because it turns out that storage really behaves pretty much the same regardless of what the underlying system is. Anybody know what a storage interface looks like? Read and write. Same as put and get. That's it. It just happens to be block oriented. The only thing you can do are read blocks. So that's why we can get away with doing this. This is why we can actually have something on the host machine that looks like a piece of storage inside of the container, and it just works, and it's got that nice feature that it's outside the container, so it's not ephemeral, it's preserved. That's why we use containers. But okay, when I'm running stuff on my laptop, I don't worry about the fact that I'm running stuff on my laptop with other stuff on my laptop because it's my laptop and I don't need to keep secrets between my left hand and my right hand. But now when you're in the cloud, your container and his container, and look at him, he's a shifty looking guy, isn't he? Well, not quite as shifty as you maybe, but you're running on the same hardware. Could you access his data? I mean, I would argue that if you can, then there's a bug. But I will also point out the fact that these sorts of bugs happen all the time. So one of the risks in using cloud computing is that it's shared tenancy, and you might not have as much privacy as you think. You know, it's like finding out that your washroom walls are all one-way mirrors. You think no one can see in, but you can't see out. That's not exactly. Have you ever been to one of those? There's the Fairmont Pacific Rim apparently has that in the washrooms where they'll have this like whole glass wall and there's a switch you can turn that makes it go opaque. And I'm like, that would just be weird. But there you go. So that privacy thing that maybe you're counting on to keep your data safe isn't an absolute guarantee in a cloud environment. If you need that level of absolute guarantee, don't use shared tenancy. What do you need to use if you need that level of exclusive control, but you still want to use the cloud? Well, then you're going to go and use a virtual machine. But even virtual machines are still shared unless you are actually controlling the entire machine. And you can do that. That's actually how the cloud kind of started, is that people did co-location. So you would literally have a physical server that you put inside of an infrastructure someplace, and it would hang in a rack. Have you ever seen one of those pictures of racks with computers in them endlessly? Do you know how it actually works in data centers these days? Most of those places, no one goes into them. Do you know what the most expensive part of a data center is at this point? The operationally expensive part.
The cooling?
Cooling. Yeah, it turns out that silicon running with lots of electricity in it generates an awful lot of heat. And so they pump a lot of heat out of there. So the last thing in the world you want to do is put people in there, because people create more heat. When things break inside of a data center now, this is my favorite part, there's just extra hardware. And they just switch to the extra hardware. And when enough of the hardware breaks, somebody actually does come in, they bring a forklift in, they take the entire rack, they disconnect everything in the rack, they pull the entire rack out, they take that out with the forklift, they bring a new complete rack in, they push it into place, they reconnect it, and they're done. There's a company, like very old company, that's been doing this business for a long time. Is that that's literally what their business is. They come in and they replace racks, and they take them back, and then they tear them apart, and they fix them, and then they return them to service. I had this interesting call a couple of weeks ago. I do some work as an expert witness, and they were looking for an expert in the international trade of used computer equipment. And I mean, personally, I haven't done a whole lot of trading in used computer equipment, but after they were having a hard time finding somebody. And after a while, I ended up having a conversation with them. And I was like, well, what does the claim look like? Because it's an insurance company. Somebody says our ship went missing, or a container went missing, or whatever it was, but it was an insurance claim. And they started showing me some of the evidence of the things that were being claimed, and I was like, where are the serial numbers? Do you know what the difference is between used computer equipment with serial numbers and used equipment without serial numbers? One actually has a market and the other one is considered to be e-waste. Why would you need the serial number? Because that actually tells you the history of that piece of equipment. And as crazy as it might sound, as much equipment as we're talking about, when they take those racks, they tear them down, they pull the parts out of them, they track every single piece because they need to know where it came from. Often, it's not just the equipment that's being transferred, it's the licenses to use software on that equipment. And if you don't have that, you don't have usable equipment. And I told that to them. I sent them a whole write-up on it, and I pointed out that this is standard practice in the industry. It's not something I made up. And I haven't heard from them again. And that's probably because they went back to the customer and said, we don't think you need an expert. But that's what happens. Those racks get pulled out, they get torn down, they get replaced, and life goes on. So you don't even know where your stuff is running. Oh yeah, it's in US East 1 in the Amazon region zone. You don't even know what physical building that is anymore. It's a zone, it's a region, it's probably 16 data centers at this point. There are 120 of them. They're building data centers very quickly. Data centers are literally built to be able to withstand the destruction of an entire data center. Yeah, a little earthquake, hurricane, tornado, fire, doesn't matter. You may not even notice that happens, unless you're using cheap tier. Of course, if you're using cheapest stuff, what you're really doing is you're buying one machine hanging someplace, or one piece of one machine hanging in some data center someplace, and if it goes away, your project is gone, your stuff is gone. Them's the risks. Even there, you might have backups. But why would you use the cloud? Well, one of the reasons people use the cloud is because it's scalable. But another reason is because it's resilient. It prevents exactly the kinds of disasters I'm describing here, which is, sorry, that computer that your stuff was running on yesterday, it's gone. It's underwater. It's gotten flooded. So you might actually be sharing with lots of people. You might not even know who you're sharing with because your stuff gets moved around. Other people's stuff that was co-resident with yours gets moved around. Their project scaled up, so they got moved to a different node. You're staying, or maybe you got smaller, so you got moved to a different node as well. This kind of migration happens all of the time, and it's largely transparent to you. So you have to think about that. Who else might be sharing this with me? And where are you enforcing your own security principles? How sensitive is your stuff? How many of you use TikTok? Instagram? Great. So between the two of them, we've pretty much covered the entire crowd. How much data do you think these companies collect about you? Everything. That's right. Welcome to the world where you are really not much more than a cow. Grazing the field, eventually you're going to become a hamburger because you are the product. Because you're not paying for TikTok. You're not paying for Instagram. So they're curating you. They're using you. They're extracting that information. And here is the great tech dream. You are now going to learn about the very tech stack you need to build your own killer app that can become the next TikTok, so that you can have enough money to be an asshole full-time. Witness. Who comes to mind when I mention, tech bro jerks? Zuckerberg, there you go. That's the Instagram tie-in. Anybody else want to? Right, he's the other one who always comes to mind. I mean, Bill Gates people used to think was a bit of a jerk, and he is a jerk, and he's in the Epstein files, but so is everybody else as far as I can tell. And he's kind of a minor jerk now in the big leagues. So the goal, of course, how many of you actually want to be Mark Zuckerberg? No, how many of you want to be as rich as Mark Zuckerberg? And how many of you do you think you won't become an asshole like Mark Zuckerberg? Oh, the doubt goes up on that one. I don't know. Well, okay, so I only know of a single multi-billionaire to come out of UBC, computer science. I worked for him for a couple of years. He started several startup companies. His first startup company, I think they sold to Cisco in the 90s for $425 million, not billion, $1 million. My God, it's like Austin Powers, $1 million. And now 1 billion doesn't sound like very much because now we're looking at 1 trillion. Elon Musk is heading that way. Over 600 billion last I checked. He did his undergrad here, did his PhD at Waterloo, came back here, was a lecturer for a little while, got a position at Stanford. I started working for him at Stanford when he had just received tenure, and he wasn't a millionaire, let alone a billionaire. Did a startup company, sold that, invested in a number of other startup companies. I think I read Yahoo, but it turned out the winner for him was when a couple of PhD students with an idea for a company showed up on his doorstep, and he wrote them a check for $100,000. They didn't even have a company yet. Today, the company that formed after that is called Alphabet. Anybody know who Alphabet is? Yeah. So the founders of Google showed up on his front porch, a good old boy from Vancouver, and he wrote a $100,000 check. His business partner at the time, Andy Bechtolsheim, wrote a $100,000 check, and it turns out that investing $100,000 in Google at the beginning of time, not bad on the investment scale. Since then, he's invested very well. In addition, Arista Networks was one of the companies he co-founded, although he's not involved with them anymore. You know, frankly, he's an asshole. I mean, I actually like him. I like him a lot, but he's very opinionated and very full of himself, and it's great. I mean, absolutely fantastic. But that's the dream, isn't it? To be so filthy rich that you can just tell people to screw off and go away and do whatever you want. Excellent. Let's figure out how you do that. The first thing you're going to do is make sure that all of the data that you're collecting about all of your customers is infinitely and safely preserved, because that's your gold mine. I mean, in essence, that is what most of cloud computing is about. It is about taking data, aggregating data, and building services that help your product so that you can sell your product to your customers. Is that a cynical way of looking at it? Yeah. Is it wrong? There you go. All right, so a virtual machine is a hardware technique for isolating different environments. It's an ancient concept. It was first described, I think, in the 1950s. So long enough ago, it's a long time ago. And first shipped in a product in the 1970s. IBM shipped it, in fact. Instead of having a single operating system on a single piece of hardware, what you had was the hardware ran multiple instances of the operating system. So what we end up with is basically an operating system that hosts operating systems. That's always end up being the architecture. So a virtual machine virtualizes a computer. We run a kernel inside of that virtual environment, and it has the strongest isolation properties of any of these mechanisms we're talking about. Typically, that's because we don't share CPUs. We can, but typically what happens is that you end up with your own physical CPUs, and that significantly decreases the surface area for attacking, because the biggest surface area for attacking is basically to just try and do things that read state that's in memory indirectly. There was a big security thing, oh my gosh, it must be like 6 years ago now, called Spectre. And before that it was Rowhammer. And there are plenty since then. They're called side channel attacks. So in essence, what they do is they watch to see how long it takes to do something, and infer from how long it takes to do something what actually happened. So they will read data in memory, for example, by indirectly referencing it. And if it's present in memory, it will behave in one way. If it's not present in memory, it will behave in a different way. Encryption is really sensitive to this, where literally the amount of time it takes to decrypt something can tell you if your key is close or not. It's very strange. I mean, this is a whole I'm being very hand-wavy here. There are people who spend a lot of time working to figure out how to actually infer what's going on inside of the black box by watching how the black box actually behaves. Containers are pretty cool. They isolate above the operating system by using shared libraries, by using libraries that separate what's running inside the container from what's running outside. If you actually look on a Linux machine and you're running Docker containers, you can see the processes running the Docker inside the Docker container. You can see them on the host machine. It's the one-way mirror effect. If you're inside, you can't see out, but what's outside can see in. So the host operating system can see, because it just looks like an application program. When we get into serverless, then this is very interesting, because these are just pieces of code. They typically do actually run inside a container, but as a piece of code, all it's doing is running some small function. That's why it's usually called functions as a service. And they're cheap. They're often where people get started when they're building cloud apps, because they're like pennies. And it takes a lot of them before you get out of that free tier and you have to actually start paying, and suddenly your credit card starts getting whacked for that cool idea you've been floating around for your startup company. There's a worksheet. Why would it list that? All right, there's a worksheet that's on Canvas. That happens to be the list of the location of where it is on my local machine. So Probably should fix that. So we create the illusion of isolation because, of course, virtual machines share the same hypervisor. So there's something in common between them. The containers share the same kernel. Isolation is a relative term. If I want to isolate my machine, then I can put it physically separated, and then it's more separated. But then we'll find out that there are air-gap attacks, and people can read things just by being in the room with computers. So then you put them outside. Honestly, if you really want to protect your computer, the safest thing to do is to go find where they're pouring some concrete and put it in the concrete. Very, very hard to get to. Of course, it's impossible to use as well, but that is the fundamental challenge of security in my experience, is that there's a lot of security people who think that security is the only thing that matters and ignore usability. But in the real world, where you're actually trying to build that killer app so you can become a billionaire or a multi-billionaire, let's not shoot low, let's shoot for trillionaire. You don't care about security as much as you care about is make it cheap, make it fast, make it scalable, because when this thing hits, I want to be able to scale this all the way up. That's what's going on with AI right now. The problem is about scaling. Right? They don't have enough resources. That's why they're building data centers as fast as possible. That's why Elon Musk built that one data center where you got portable generators using propane. Because there's no environmental issues on that one, right? Oh, and the best part is once you get to that level of wealth, you can just simply hire attorneys to keep people tied up in court forever. There's something to be said for people who've done just coming and saying stop that. It's primitive, but I'm not sure it's worth sometimes. Okay. Shared infrastructure means there's a shared resource. You just need to be aware of it. You just need to think about that. And a lot of what we're going to be talking about throughout this course in this class is making things that you haven't thought about visible to you, so you start thinking about them. These are all trade-offs. This is a huge space of lots of different trade-offs. Why do I use serverless versus using containers? Why do I use containers versus using machines? Why do I use that at all? Because if I'm doing maximum security and maximum control, I put it on my own machine. I think I mentioned this before. The industry number is that about 50% utilization of hardware that's in a data center. In private cloud, which is the server hanging on racking your own machine room, that number is 12%. That's why they can make money and charge you less, because they're utilizing the same hardware just far more effectively. But you are buying trade-offs there. So if you're promising isolation, you need to make sure that you're specifying what you're doing to deliver that and how you verify that you are truly in that level of isolation. We're going to see this over and over again. When you start making a promise, you need to be able to make sure that you are actually doing it. This is test-driven development, but it's not test-driven development about does the software work right. It's test-driven development about does this piece of tech satisfy our contract. So there's this very interesting exploit on Palo Alto site about Azure containers. Does anybody know who Azure is? Nope. Microsoft. So Microsoft Cloud. I know the CTO. He's worked for me. Here we go. He's on the program. I'm not sure he's doing it, but probably. That's all good. So there are details about this. They don't actually go into great descriptions of the exploit. And that's not uncommon these days because, especially for vendors, they don't really tell you how things are compromised. Most of what they're going to do is tell you about how wonderful they are for detecting it and fixing it. They don't really say, well, you know, we kind of screwed up a lot in the first place. It was an HPE CD I just saw in the last 2 weeks where it was nearly a 10 on the criticality scale. It was, we allow anybody to run anything from a remote to this port on our machines. And I was, what? And the fix was to lock down the network access to that port outside of the machine. So their own infrastructure, their own mechanism for managing security relied upon the ability of anybody to pop that port, exit anything they wanted. And you're like, you just leave the keys in your car on the street in downtown Eastside and expect it to be there when you come back? Does anybody know what downtown Eastside is? Anybody have a car? If you park downtown Eastside with keys in it, you're gone. And these kinds of things just shock sometimes. So you start reading these actual security incidents, descriptions, and you say, well, this is really bad. And last summer, Microsoft had one with SharePoint where anybody hacks anything with no credentials at all. And you're like, what? I just compiled that. You know what? I'm sorry, I can talk about that. Okay, instead of muzzling you. So shared tenancy tells us that in fact the only time you have a managed service is because you're not the only one using it. If it's just you, then they give you the management console and make you responsible for it. That's fine. Containers are not a hostile multi-tenant security boundary. Right, because they could be trying to hack you and you have to assume they are. This particular case was an escape, so somebody inside the container figure out how to escape the container. You know, we put a dangerous animal inside of a cage and it got out of the cage. And then we're all surprised when someone can movie out of it and it eats lots of people. Look at this particular case, this is tech, so we're not really going to eat people. What we're going to do is steal data, because that's more valuable. If you really want to be rich, go data broker. Start building IT stacks for organized crime organizations, because it turns out that most of them actually would really benefit from having IT people to build their stacks out there. There was a particular class from when I was teaching, I was talking about pixel operations and what happens. As I'm starting to talk about these things, you can actually have a whole stack of all the IT needs for pixel operation. What is a pixel operation, right? And you couldn't tell apart from putting a corporate sale of product. Anybody know what a pixel operation is? Not literally. It's a figurative pixel operation. I can create from the Wall Street Journal. Have you ever received a sorry wrong number text message? That is the sphere tip of pixel operation. What they're trying to do is actually get you to respond, and then to see if they can convince you to engage with them, and then over time what you try to do is build confidence with you, and ask like your friend, and eventually somehow they'll monetize you. You're a little too young and cynical for that. I'm not nearly so young, but I'm equally cynical, if not more. I actually explore these things. I'm like, where is the angle? What are they doing? How are they making money? And they all have different angles. But what's interesting is it's happening in real time. So in the United States, they actually unsealing that doing some guy in Cambodia, and at the same time, because he's running a pixel operation, at the same time, they also seized part of the Bitcoin operation, $15 billion. That would be dollars. Now the way these operations actually work is they kidnap people often in China, and then they take them to Myanmar, all using Cambodia, so they're Cambodia too, obviously. And they literally keep people at gunpoint and they make them work. And you see these like pictures of mobile devices. And they just have like a huge array of mobile devices. And they run multiple conversations through these mobile phones while they're talking to people all over the world. And I was thinking, this is why we need AI. These people have enough money, $15 billion for one person, and they can train as a fucking model. So you want to make money? So a big fucking operation with no people involved. Now, I am not going to make a ethical decision. I personally am not going to do that. I can see it, and I can see it, I'm sure someone is doing it. But this is our tech. You can solve real world problems, even if they're not problems that you necessarily want to be solving. On the flip side, somebody can come to you with a very reasonable sounding description, all the tech stack necessary to do this. And you're like, okay, yeah, that's fine. It's one of the common ways of doing this is in fact to do fake investments. So somebody comes to you and say, what we need to do is build a portfolio construction software package, and in order for us to test it, we need to be able to create fake data so we can actually look at it and make sure that it looks right. The fake data is really what they want. They want something that looks very plausible, but the fake data now gives them the ability to basically get people starting investing. So send money in and it goes in their account and they see that their values go up and up and up, and then look, oh, down a little bit, and they play the whole con game for all this stuff. I wish I could say I don't know people who fall into this. Mostly I know people whose older parents have fallen into this. And often numbers are measured in hundreds of thousands. One friend of mine, he paid his father lost about £250,000, which is a considerable amount of money. So, oh, and that's what he's already. Who's the billionaire chief? Yeah, because like 2 weeks after that event, Sterling shut down like 2,000 downlink sites in Southeast Asia. And you're like, 2,000? That's a pretty significant scale. Oh, just in case you want to maybe run here next to yours. So, yeah, really not. It's just what it works. Let's see, let's see. So we have cost control test. Every claim we need to have what we're guaranteeing. Where do we guarantee it? Do we guarantee it in our API contract, or is it part of our privacy promise, or our individual license agreement, or service level agreement? How are we going to control for this? How do we make sure that we're enforcing it? What's our test? Now, here's the interesting thing. You need to start with the test that fails before you implement control. And the reason for that is because once you implement control, the test is going to pass. So if you implement control and then you implement the test, you don't know if the test is working right. So ultimately, you have to identify where this control is enforced. You can actually use multiple enforcement points. You don't need to just rely on a single one. That's just a good thing for safety. The control rubric is actually on canvas. Ethical license is considering your building cloud applications when you're using the cloud. Who's affected by what you're building that you're not considering? And this is not something I'm making up. This is actually a traditional way of considering impact beyond your immediate customer. Personally identified information. This is really important because not only is it in fact ethical consideration, it's also something that becomes legal consideration, depending on the jurisdiction where you're operating. So what personal data are you collecting? What are you using it for? Why are you collecting it? How are you safeguarding it? Do you know what happens when your personal data is actually compromised? About 20 years later, you get $3.87. It still might be hard, right? I've had this happen a number of times, and I've watched the settlements, and settlements are almost always very, very, very small. You know wins in those kinds of class action settlements? Sorry? Yeah, the lawyers. Class actions are not free. So people spend money for them. You know, you start off people to app, you go, okay, this is great, you share with your friends, okay, it's a little bit easier. And then your friends share with their friends, okay, screw it, over here. And then suddenly it's picked up and somebody shows on TikTok, and next day you get this notification from Amazon Web Services that your bill is now $700. And the day after that it's $20,000. And then after that, off because your credit card is so low. No longer charging, no longer working. So what happens is you start with a really cool idea, you build the app, and then you say, how am I going to pay to support this app? And there's a variety of ways of doing this, but probably the most common is, what do you see on Instagram? What do you see on TikTok? What do you see on YouTube? Right. Advertisements. The moment that you decide that you're going to start advertising, your customer is no longer the original customer, but you wanted the functionality of the app. It now becomes someone who wants to monetize the ads that you show to the people using your application. And like it or not, that changes your perspective. And it's actually really interesting to watch how companies go through this. Oh, we won't share your data, and then they change the terms of service. Anybody ever had a notification? We update our terms of service. How many of you have ever actually read terms of service? Why not? They're too long, and your only other option is right. Now decline. There you go. That's not really close. And then this is an interesting one, which is how people use information. So we built this really cool thing for tracking what people's bags are. And then what we find is that somebody can attach one of them to your car or your bag or you in some way, and now we know where you are. Then you need to stop people. Okay. There are 8 sample projects available in the GitHub repo. It can be called taxones. It's a very unoriginal name, but it's easy to remember. So these are examples. You do not need to use these examples. You don't need to build a taxone that follows these examples. You can build something that is different than these examples. They were just simply built to try and provide those who look and say, I have this much imagination, I have just used one of these, an opportunity to escape that. I don't think anybody last term actually used them. That's why we usually stop, right? Would you expect I use Claude, create them? Actually, I use ChatGPT, create them, but it didn't make any difference. It's examples. And the beautiful thing about using AI is that the examples that we generated today are different than the examples that we generated 4 months ago, because none of the models we used 4 months ago are currently used today. I wish I could say that wasn't true, but I think it is. The taxon can be done individually, done in a small team up to 5 people. The expectations are that if you're going to do a 5-person taxon project, I expect to see the output of about 4 people. That's not bad. Honestly, what I actually saw last term was a team of 5 people, gave me the output of about 0.8 of 1 person. So we just call it business linear slowdown. You know, the more processors do it, the slower it came. And I was making it up, but it actually isn't uncommon for programs to do that the first time you run them. Oh, look, there's not a lot, it's like 1. Great. The evidence trail is really important. I would like to see if you actually get something running, because that's nice to see. It makes you feel like you actually engage the cloud. But if you decide you were going to build, what seems crazy, like a new payroll system for the Canadian government, this seems like you guys. Go do a search on the Canadian government's payroll system. Nightmare. I don't think it's working now, 5 years later. 6 years ago, no. It's a disaster. I mean, there are people who are not paid for a year. What is something interesting? One interesting project was actually how do you provide contact medical records for Indigenous people in Canada? And you know, it's fun. All of the pre-existing solutions are going to assume the laws apply to non-Indigenous people in Canada. So you actually build something different because the rules they use, the laws they operate are different. In Canada, the default is you have the right to your own privacy when it comes to your medical records. In original laws, that's not necessarily the case. The community itself actually has rights. The family has rights that are not constant with Canadian law. So it's an interesting project. A little more complicated to build. That means you have to actually choose carefully what services we're going to build. We will touch on PI more, but the rules of PI depend very much upon what jurisdiction is. If you are going to build something using Canada, you will have a different set of rules about PII than you will if you're using Canada or the US or Europe or even other interesting examples. India and Brazil have interesting different behavior protections for PII. So the first design I can actually do next month. So you still have to wait for that once you're paying in advance. But this is where you're going to go through a design cycle. And that's not the capstone design you're working on. This is you're working on designing a pre-project. So you just go through that and get familiar with what that pattern is. And then as you're starting to have that, that's going to be the capstone design. The idea is that you follow around with the first design, and by the time it's starting to make sense, you enforce it by having to do it in 1 hour. So what time is it? Let's see here. Yeah, wait. I was thinking how long I have these videos. I do. Wait, 11, 19. All right, fine. These are all on Canvas. And now I'm using these videos without the actual links to them. It's supposed to be ready to push Canvas. So maybe we should talk about this stuff. Since I'm talking about the claims one, so what I did now is for us to take some time and actually build something really fun, that's for sure. Actually build some claims. It doesn't matter what they are. If you start thinking about this, take one of the examples, take one of the captions, look at it, use that as an example. So you can work on this on your own. You can use it in that in the group. Setting the sit down, start talking, ideas out, and then look at what you're promising. And use only the top, for example. You can't think of anything else. It's like how do you protect the AI? If there's no AI, then the question becomes, okay, so we're going to how do we make sure there's some people AI in project that we notice it? So start saying like that. Let's do 10 minutes for that, and then get back together and both actually need to try and this, which is one claim. And one example, how you recommend it to a control test, control test example. So it is, I'll go start timer. Yes, sir. Yeah, I mean, you come up with something, you say, no, stop about it, and how and even different tools to choose from. So instead of saying, like, choose those tools on a project where they fit, and that's kind of how you do that approach. It's more like find something that you think is an interesting problem that you believe will actually require some level of cloud usage, and then you use this problem and identify what you need to use. Yeah. Sure. I mean, you have a motor wiring on a virtual machine. So the idea is it's not, so, okay, so for example, do you know what cloud gaming is? Okay, so everybody's a game console? Yeah. All right, so one of the things about gaming consoles over the years is they actually age out, and so your PS3 games, you'll play on your PS5. But now they do, and the way they actually do that is they actually run the PS3 game in the cloud, in a virtual machine. And you use a virtual machine to run your GPU, and obviously there's a little hardware required there. And then what the problem is they built an interesting protocol that moves the graphical information necessary across that cloud boundary. And then that works now fast enough. So that's an example of a very application that's a virtual machine. I have concrete reasons why I need it. Right, you need it. Or if I'm going to say I'm going to build your competitor DocuSign, for example, you put it in the cloud because you need to control it from a security perspective. So something that can be spoofed if it's locally, but can't be spoofed if it's on the cloud. It's hard to spoof if it's in the cloud. Yeah, I know what I'm actually. And he literally ended up building an entire level in on the web, so that you could walk up to this thing and run all the tooling that will normally run for development locally. Now, there's an interesting use case where he took something that's typically local, but he pushed it into the cloud because he was using an interface and didn't have anything to actually store locally. So he was remote desktop solutions. So there are those capabilities you can use to build something like that, but don't, if you just take something locally and push it in the cloud, then it's just a lot of problems that solve this task.
I think it went late, so I think I did the first one.
The only thing is, I can do everything we said is 20th January, next Tuesday. Right, so if it says it's time, he literally sold it. So you just have to do it. You don't actually think that we can do until Thursday? This week, I remember. But yeah, there's nothing that has a whole set after the date before the 20th.
And about there's
a huge long list of this stuff. It's if you go to let's see, the green view. You look at here. Let me see if I can find it. Just go get myself that. It's not giving me a bar. This is being active. Okay, so let me see here. You can pull up. And this. I have it now. It's a whole series of small activities over the course of the term. There's nothing that you use in class that counts inside, but there are things that you do that are. Now, I have to look because I have two classes, but not the same. One is different than this one. Let's see. Gee, look at that. It's already working again. It's not anymore. Some other stuff. Let's see. So I think from the design is very interesting step right now. The design pack, that's what I was talking about. Fifth, the C through 5 the cycle that goes on. That's where you people you're going to be able to see energy version of feedback. None of those are for greater now than sufficient. Right? You just need to do it because the purpose of exercise isn't because it's because this will help you see on pass. If you want to see that, then I didn't need it in case I wasted my time, or B, didn't need that you should see it in case you don't know me. As far as my philosophy, which is I don't want to be. I don't like what education means. Normally people want metric. Everything comes about that metric. I punch it for some proposed in the idea of 14 thing. And I was going to for 16 because I did the same deal, which is game theory teaches the best strategy is to go. But so certainly the strategy game theory the answer sheet. And second one is good arts law, which is really interesting. That's really interesting. And then the basis of your evaluation, you end up destroying science metric. So the way that medication is, we use it's incredibly important that all of your is number. I'm like, let's try to easily. I must right? I don't think so. The idea is that you're either a graduate probably. You need to be in habit of learning. And I'm only involved in that. I saw you stuff that's going to be and I'll try to play it out. Because I'm fine. Yeah, that's fine. Yeah, right. You need something that is all it's really simple. It's really simple. I'm not going to do the right part, but yeah, that's right. I'm not concerned with that, but honestly, it's not much. No, you wouldn't. I wouldn't put you about this. I do this, but it's going to stop right now, so hold on. Okay, I'm going to stop here. After that, we're going to go through this. Well, already, there's a 5, or there's a 5. All right, so, okay, so did you mention the control test example? All right, well, this is the homework. I want to look at this. This is what I see when you guys log. So next week, the goal is to get the DAs to start looking at your data and providing you formative feedback. It's not an evaluation of it's a score values. This is what you're doing right. This is what you want to strengthen. It's just feedback for you to know whether or not you're demonstrating how you're learning and hoping to demonstrate. Of course, the important part of that is figuring out how you can fix this area you made. Never had a question for. Most of the things this is necessary. What you think that made. How's your marks? A lot of any of us in this room. Okay. This one I actually did. I'm going to basically say work on it because this is the kind of thing you need to think about. This how do you test your talent? I didn't say it's a different way of thinking about tests. It's like how can I test to make sure that I'm actually doing things that my company is ready to do. I would put the last note. One of which is since you're starting off as junior developers and organizing the first asking very good tests to make sure that we're protecting our customers' data properly. And actually you just out of your head and what? We don't do that here. Introducing the follow-up email that says just confirm I'm not supposed to write tests to verify that we're obeying the privacy promises we make in our public-facing documents and make sure you copy that email out to me. If you don't, because you lie. If you get sued, I guarantee you that management will blame you. And you'll just sign. I hold this basis for in the industry, and they're all like, yeah, that's absolutely right. I've seen that many times. So the goal is to get yourself none of these. Put it into your email. Sign it. Not hard. And we can do this because you guys like to put things in the so we'll see that. And then this is me. I'm going to come up with any of them. Okay, so I'll do that next week. So, and every opinion, number 1 should go in class, and it should close before the next class. These are important because today are your opportunities to start working, and my objective is to close on Thursday afterwards because I'm going to do some analysis and see what it is happening on these so I can make changes now. And I'm doing that really throughout the entire course of the term because I'm not here to make life help. I'm here to help you learn something. Even if something is half study. I want you to have tools to be successful in the university. Congratulations, you're investing your money. That's graduation, basically. There we go. That's it. I'm going to today. I have a couple questions, so feel free to ask the questions. I'm going to stop the stream, stop the recording, and if I'm lucky, I will get this thing uploaded here in class. I did that for 4:16 because it's wait 2 minutes before it stops recording. I don't know what it's doing. Yes, student. Yes. Yes. I'm going to technology stacks have a habit of failing.